In this section, you learn all about sets and set notation. And so I just want to go through a couple examples of operations on sets just to kind of get you more comfortable working with them. So one of the first operations on sets that you learn about is unions. And with a union, you're just taking two sets and just combining all of their elements and getting rid of any repeats. So over here we have the union of the set with like some random things in here. So I have 1, x, and 2 are my elements of the set. Here my set contains the elements 5, b, and c. And so the union would just be the union of all of the elements. So it'd have everything that shows up in either set here. So this is my union. However, in this example right here, we see that we have some elements which repeat in both sets. So we have A, B, C in the first one, and then B, C, D, E in the second one. And so when you do a union, you would not want to write something like A, B, C, B, C, D, E. You would want to not have any repeats of anything when you write sets. And list all of the elements without having repeats. So this would just have A, B, C, D, E. If you want to look at intersections, that's the next thing that next operation that most people see. You would basically just look at what elements appear in both sets. So with unions, you have to pay attention to repeat elements, and intersections is really just asking what are those repeat elements. So the intersection of these two sets, ABC and BCDE, would just be the set containing all of the elements, which would just be B and C in this case, where B is in my first set, ABC, and and also in the second set. And of course, C also satisfies this. So B is an element of the first set and an element of the second set, and also so is C. One thing that you should notice here is that whenever you take an intersection of two sets, so B comma C right here, this set is strictly smaller than both of those other sets. Everything that's in this set is also contained in both of the other sets. Basically, what that means is that this intersection is a subset of both of the other sets that you did the intersection of. So BC is a subset of the set A, comma B, comma C, and also it's a subset of B, C, D, E. All right. Similarly, whenever you take a union of two sets, so up here we have the union of these two guys. When you take a union, you get something that's strictly bigger, and so you could say that this set is going to be a subset of the union of it and something else. All right, let's do one more intersection. What if there are no elements in common? Then what would you say the intersection is going to be? Well, 1, x2, 5, bc. So there's nothing in common between these two sets. And so we would say that the intersection of these two sets is empty. So we would call this the empty set. You could write this in a couple of ways. The way that I just did is the most common. Technically, you could write this as just a set with just nothing in it. You could write it like this. But people most often will just write this as a circle with a diagonal line going through it. So this is the empty set. Notice that the empty set is still a subset of both of these sets that you took an intersection of. This is actually what's called a vacuous statement. every element in the empty set is also in the set that's bigger than it. That is a statement that is technically true because there's nothing in the empty set. So yeah, sure, it's true that everything in the empty set satisfies some property that I'm trying to impose on it. It's called a vacuous statement. All right, differences. When you take a difference, you take this set minus some other set. You take what you're doing is you're taking everything that is in this set that is not in this set. So in here, but not in here. So what is in the first set that is not in the second set? So you could just do this one by one. So A is in the first set, but it's not in the second set. B is in this first set, but it's also in the second one, so B would not be in there. C is in the first set, but it is not in the, but it's also in the second set, and so C would not be in the difference. So the difference just has A in it. And the difference of 1x2 minus the set containing 5, B, and C. So this one, there's no elements in common, and so the difference here is very easy to do because everything that's in here is not in here, and so we don't really have to get rid of anything. So this right here would be our difference. And on the subject of subsets, we could also say that that anytime that you take a difference, this difference is a subset of the first set that you started with. Not the second one, though. In fact, if you were to take an intersection of the difference with the thing that you subtracted, because you got rid of everything that's in this guy, the intersection of this guy and this guy should be completely empty. So there's nothing in here that is also in here. Okay, and one last thing, actually, products. So I'll do this one pretty quickly. With products, you basically do, this one is very different from the other operations, but with a product, you just do a bunch of, coordinate pairs here. So you do things that look like something, comma, something, where the first thing is from the first set, and then the second entry is from the second set. So the first entry that we would, the first element of our product would be A comma X, because A is in the first and X is in the second. We would also have A comma Y would be in there, and A comma Z would be in there. And then we could also have stuff where we have B for our first element, or for our first entry of our coordinate pair. So we have B comma X, and then B comma Y, and then B comma Z. And this would be our product.